Okay, so in part F, it says find the total distance traveled by the particle during the first 5 seconds. So it says at 5 seconds, I want to know where the particle is, because the first thing that I knew about the particle is what it departed from 0, it got to position 4, it went back to 0, and then it kept going right, and I don't know where it stopped. So since we're considering the first 5 seconds, I just want to know what is S of 5. So it would be 5 cubed minus 6 times, what is this? 5 squared plus 9 times 5. And that turns out to be 20. So the particle is going to go right, and at time equals 4, let's say that this is 20. It's not, but let's say that it is. At 5 seconds, it will be over here. So they are asking us for the total distance traveled. So I know that it went 4 units this way, plus 4 units this way, that will be 8, plus 20 units this way, that will be 28. So I can do 4 plus 20, and that gives me 28. Since every unit is worth how much? 1 meter. So I would say that the particle traveled 28 meters. Now, if I don't want to do it that way, if I want to do it algebraically, then I have to calculate what is the distance that the particle traveled between 0 and 1, between 1 and 3, and between 3 and 5, because these are the parts where the particle turn around and switch direction. So I want to know how much it went the first time the particle went right, the first time that it went left, and then the second time that it went right. If I only do S of 5 minus S of 0, then the only thing that I'm going to get is 20 minus 0, which will be 20, and that will be wrong, because if you're doing the difference between the position at 20 and at 0, between 5 seconds and 0 seconds, then you're only counting the distance apart from it, and you are not considering this. And when it says the total distance traveled by the particle, then you want to include everything, even when it went back and forth. So that's why it's important to keep track of when the velocity is 0, because that indicates, okay, the particle went this much right, the particle went this much left, and then the particle went again this much right. So this is 4, this is 4, and this is 20. And all of them should add up. If we're not taking the absolute value, then these two will cancel out, because one is to the right, one is to the left, so that will be 0. So we're going to talk about those differences later, but since the numbers are low and you have a diagram, so then let's do the diagram to figure that out. Now for part G, it says find the acceleration. So we went over this before. Acceleration is just the derivative of velocity with respect to time, so or v prime of t. So I'm just gonna take the derivative of v, and where I have, oh, so the derivative of v will be 6t minus 12, because the derivative of 9 will be 0. So I found the acceleration after 4 seconds. I will just have to do a of 4, because a of t is for any t. Now a of 4 will be 24 minus 12, and that will be 12. Please make sure you do write the units. Velocity was meters over second, and acceleration, because you're taking the derivative again with respect to time, that makes second times second, which is second squared. Other books may write it like this, meter over second again. I like this one, this is simpler. Then part G says graph the position, velocity, and acceleration functions between 0 and 5. So this is something that I can graph. This is something that you have it graphed in your handout, and I'm gonna go over that in a second. But just to show you that this is a very easy graph to do, Okay, so this is t, and we're gonna go by ones. So the function s is t cubed minus 6t squared plus 9t. So that's a cubic function, and it's gonna look some kind of like a snake. Now you know that s is 0 when t is 0, so I know it's gonna go through this point. And then at t1 was 4, so I know that one, so it's gonna go like this. And then at time 3, you know that it was, what was it? You know, at time 0, and then at time 1 was 4, and then at time 3 was 0 again. So I know that this function is gonna hit the x-axis again over here. And then after that, then I think it's 20. So it will just go like this all the way to 20 by the time that it hits 5. So it's even more inclined like that. Okay. Now the velocity function is 3t squared minus 12t plus 9. And you know that that factor out at 1 and at 3. It was 3t minus 1, t minus 3. So I know that the zeros are right here. So let me do it with blue. The zeros are right here, and you know it's a parabola. So it's going to go like this. Okay. And the y-intercept is 9, so it's going to intersect the y-axis at 9. And it's going to go like that. So that's v. And then the acceleration, I'm going to do it with another color. And you know that that's a straight line, 6t minus 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y-intercept is over here, and then the slope 3, 6 over here, and then 1 over, 1 up, and then 1 over, 1 up, 6 up over here. So it's going to be a straight line that goes like this. So this is to a scale that is different from the one that you have in your handout. But we can use this one, or you can use the one on your handout as well. It says, when is the particle speeding up? So speeding up is related to speed. So if you were the particle in a particle car, what would you see in your speedometer? So if this is the velocity, you see the velocity being, I don't know, 6 meters per second, 5 meters per second, 4 meters per second, 3 meters per second, 2 meters per second, 1 meter per second. So all the time between 0 to 1 seconds, you know that you're slowing down. So I know slowing down is between 0 to 1, okay? But what happens between 1 and 2? What happens to your speedometer? You know that the velocity is negative because you're going in the other direction, but what does your speedometer say after you go through the 0? Your speedometer says again, you know, like 0.5, 0.6, 0.7, 0.8, 0.9, and so on. So your speedometer is actually increasing. The only thing that the velocity is here under the x-axis, and it has y values that are negative. The only thing that it's saying is that you're going in the opposite direction. So I know that I'm speeding up between 1 and 2. Now from 2 to 3, I'm just talking about the time. Between 2 seconds and 3 seconds, you know the velocity is going up, but the speed is decreasing because your speedometer would say 1, 0.9, 0.8, 0.6, 0.7, because remember, your speed is the absolute value of velocity. Your speed only knows the number, doesn't know the direction. So the speed here is going up. So between I'm sorry, your speed is going down, so your speed will be in between 2 and 3 going down. Oops, sorry. Okay, 2 to 3. And then after 3, or between 3 and 5 if you want to talk about it. Let's just say after 3. And after 3, what's happening? The velocity is going up. It's 0, now it's 1, now it's 2, 3, 4, 5 meters per second. So speeding up between 1 and 2, or you can write it as t between 1 and 2 like that, and then for t greater than 3. And then the other cases you have from 0 to 1, and then from 2 to 3. Now, the other thing that the book mentions, and it does make sense here, and I'm hoping that you can see it, but if not, this is something that will come in coming attractions, is that in here, for example, between 0 and 1, the velocity is positive and the acceleration is negative as a value, like above the x-axis, below the x-axis. So velocity is positive, acceleration is negative. Therefore, that means slowing down. Now, between 1 and 2, the velocity is negative because it's below the x-axis, and the acceleration is negative because it's below the x-axis. So when the velocity is negative and the acceleration is negative, that means speeding up. And then in this case, between 2 and 3, the velocity is negative, the acceleration is positive. So velocity is negative and acceleration is positive. So that also indicated slowing down. And then the last case, after 3, the velocity is positive, the acceleration is positive. Both of them are above the x-axis. So when both of them are positive, then that means speeding up. So as a summary, the book was saying, if the velocity and acceleration are of different signs, then the particle slows down. And if the velocity and acceleration have the same sign, then that means speeding up. Even if both of them are negative, that means speeding up, because your speedometer would be going like from 0 to whatever it is that whatever velocity you're riding at.